have any new content that I can cover in there, and there's no way I can add more substance. What I'm going to do instead, because 9 classes is a little bit too little, I'm going to have a video uploaded on 2 things. The first thing is going to be some exercises, actually just one exercise with multiple parts that I have put onto Moodle that I'll show you. And second, in terms of what market research can do, what you're doing right now is the first step onto a ladder which probably even I haven't gotten, even 10% over. So there's a lot of other things that market research can do. So I'm going to have about a 20-30 minute presentation first on the problems that I've given you. I want you to try and solve them on your own and then look at the solution. So that's number 1. And number 2, in the future, if you decide to go with, not if, you will have to go with 3054, most of you, but if above and beyond that you decide to go into 3090, you want to work in artificial intelligence and machine learning. I know these sound very fancy terms, they're not. Then what can marketing gain from these? And there are some very good examples that I can share with you, so that's what I will do. Again, none of this is going to be accessible. All of this is going to be, totally for your knowledge, nothing over and above that. The first part, however, is a solution to a set of questions that I put on Moodle. So let me take you to Moodle first, and let me share my screen with you. There we go. So, where is Moodle? There we go. So the Moodle screen, everything else is exactly the way it was. Sorry, wrong class. So what's going to happen as we go through the tests, what's going to happen is that you will be given some new data sets. And notice that all of these data sets are in Excel. So these ones are small tiny little data sets. Each of them has just 2 or 3 columns, which means 2 or 3 variables that you can analyze. So the first one that's available for you is called movie liking. These are all real data. Okay? None of these is made up. It's from small little experiments that some of my honors students have run, that some of my PhD students have run, some that we have run for other things. So the first one that's available to you is called movie liking, and I've given 2 possible questions. This is not a comprehensive set of questions. In fact, I would really suggest that you think about a few questions that you can make on your own from this data set, because that's what you are going to be doing for your project and kind of what you're going to be doing for your finals too. So try and come up with questions that you can answer from this Excel sheet. So let me show you the Excel sheet. I'm showing it to you in Excel, but you will obviously have to open it in SPSS, and I'll kind of show you how to do it. I won't walk you through the entire process, but it's really simple. So let me click on movie liking. So wrong window, let me just get this, drag this in here. There you go. So this is the data set. It's a really simple data set. As of right now, you will not be able to use the first column. Okay, we'll talk about what the reason is and so on later on, but you will, as you go along, you will have the option of using the first column too. What you will have access to are, by the end of this lecture, you should be able to use the second column, which is age group, which is nothing other than me having grouped this age into 5 different categories. Okay? So the first category, I think, is 1 to 25. The second is 25 to 35 or so on. Don't worry about what it is. Just look at these being an ordinal variable, where 1 is the youngest group. 5 is the oldest group. So 5, I see a 5, so 5 is above 60. Don't worry about what these groups are. That's not something which is central. Then what I have in here is the gender of the respondent. So whether the respondent was a male or a female. And on a scale of 1 to 10, how much they liked Toy Story and how much they liked Spider-Man. So those 2 movies. This is Toy Story 4 and I think Spider-Man Far From Home. I forget what these are, but whatever these are two movies, and I've given you two possible questions that you can analyze. And please, before you look at the solutions, before you see the solutions Tuesday of next week, try and do this on your own. Write down the null, write down the alternate, try and run the test, and if and only if you're not able to do it, do you resort to the video. Even if you are able to do it, please feel free to have a look at the video and confirm that the answers that you have are correct. So I've given you two questions. The first question, who likes Spider-Man more, men or women? And what about Toy Story? So I'm considering this to be one question. That's relatively easy to do. The second one, this is slightly more difficult, but again, something that we've already done. Okay, so experiment with it. There is nothing wrong in getting answers incorrect, okay, because even today when I look at a problem, the first iteration is very different from my last one. So it's it's something that you learn over the process. So the second question is, I've talked about the top two boxes. The top two boxes are what we call our focal output in marketing. We want our consumers to rate us at a 6 or a 7 on a 7-point scale, a good and a very good on a horrible to very good scale, or in a 10-point scale, which is what you have in Toy Story. I want either a 9 or a 10. Okay? So if it's a 9 or a 10, then people love my movie. People are satisfied with the movie. If it's less than that, people are not satisfied with the movie that I'm showing them. So the question is, are people satisfied with Toy Story, and are people satisfied with Spider-Man? So two questions that I've given you. Try and work through these. I will work through these and put up that video, which, and again, I know next week is off, but if you still want to ask me questions, I have no problems. I can sit down and have a chat with you about anything or everything at all. Okay, so that's number one. Number two, week 6, again, we don't have a lecture, but week 7 you have a quiz. Okay. So what is the quiz going to be? I'll obviously send you a mail in week 6. Actually, I'll be sending it probably end of this week once I've had a chat with all the tutors. So I'll send you a copy of that. But we are not going to be doing anything more than t-tests. I'm not going to assess you on anything more than t-tests. We might be spilling a little bit over t-tests today. So there are 1.5 t-tests still left over. And after that, we'll start what we call a NOVA. A NOVA is not going to be tested. It's only going to be till t-tests. Okay. The questions are going to be very, very similar. They're going to be short answer type. You will probably have to write a null and an alternate, or just an alternate. I don't know, I still haven't made the questionnaire, the quiz for you. The only thing which is still under doubt, because I have not received any confirmation from IT, is that whether or not you will need to log into SPSS. I would like you to be able to run a few tests on your own. Although I'm absolutely confident that most of you are spending time on this, but I would want you to try a little bit of it in real time. But if that doesn't happen, what I'll do is I'll module the results in such a manner that you will not need anything outside of the question paper or outside of Moodle to be able to come up with answer all those questions. So I will probably be able to let you know by the end of this week. IT has just not been very forthcoming in terms of answers. So let's assume for right now that you will have to access SPSS from home. So that's what the form is right now. Okay, before we start off, any questions on any of this? If anything else crops up, please feel free to message me on Teams. Okay? Like I told you, I'm really, really good with Teams. Okay, so let's start off. Now, I'm going to assume that you guys are looking at these slides. Again, I would hate to just walk through these slides. That's not something I want to do. Even when we have proper lectures, I don't always follow slides, but right now it's important that we do not follow slides and look at something which is visually a lot more appealing and doesn't put you to sleep, and probably gets you in the frame of mind of your analysis. So we had a little bit of a look at independent samples t-tests last week. We are going to do that again today. Spend a lot more time on this. We called it the independent samples t-test. It's also known as the independent t-test, and then you had the one sample of the simple t-test. So that is not even a problem in here. But look at the slide, and obviously I'll kind of put everything into that box that we have been working with, but have a look at what it says. It's central around the number of groups or samples. How many groups do you have? How many samples do you have? And this is a straight pick from the book, and this is why I hate the book. They use terms which are not marketing. They use terms which you need to have statistical knowledge about. Not that there's anything wrong with it, but we are going to not use the term samples, and we are just going to go with segments like we have been throughout. Okay, but this is the primary slide that we are going to be working on. This is what you're going to see in books. What we are going to look at is what makes more sense in terms of interpretation. Okay, so let me start off with where I left off. So we have looked at segments, one segment, two segments, and we are going to consider greater than two segments. I forget which one I use as columns and which one I use as rows. Doesn't make a difference. The answers are always going to be the same. The test is always going to be the same. And then you have questions. How many questions are you asking? How many questions are you analyzing together? Together being the central part of it. One question, two question, greater than two questions. Why do we not write three? Because there is a simplified way of addressing anything that's more than two. So we will consider that. We'll look at that rather than anything else. Now, I made sure that I changed my batteries, so my drawings should hopefully be a lot more smooth today. Hopefully. So we started off with, and again, I'm probably repeating myself, but it's better to repeat myself and you being clear and me trying to drive home everything to you rather than not doing it, assuming that you remember everything. So we started off with the simplest of scenarios where we have just one segment. We are not dividing people. We are looking at the entire sample at one go. Again, it's a sample, and from this we are making predictions. And that box was called the one sample t-test. What was the one sample t-test? The one sample t-test was one group of people, just one group of people, and how many questions are we asking them? One question. We are analyzing one question for one group. That's the easiest of tests, and this is going to be the test that you are going to run for the second question that I have put on Moodle. The first question I'll let you do that. From there, we had moved on to this box, where we are dividing our sample into two groups. Two groups, nominal or ordinal, whatever it is, two groups. Educated, uneducated, male, female, high income, low income. So it's two groups of people. Income is an ordinal variable. Education is an ordinal variable because there's an order, low versus high. There is no such difference in males versus females. There's no such order, so that's a nominal variable. So two groups of people and one question. Who gives more importance to XYZ? Which of the two groups gives more importance to comfort? Which of the two groups gives more importance to speed? And we did a very rudimentary test last time. And the test that I showed you, which I'll show it to you again today, is one of the worst that you can run in terms of the result. We'll talk about why that is the case. This test was called Independent Samples T-Test. Why independent samples? Once I break it into two groups, once I break my sample into two groups, there cannot be any overlap amongst them. That's a very important assumption that we are making. There will be times when there will be overlaps, not in 2052. In 2052, when I break it into two groups, those two groups do not overlap. That's why it's independent samples, two samples that are different from each other, that are independent from each other. If you're a male, you can't be a female. If you're a high income, you cannot be a low income. So those two groups are completely different from each other. That's why independent samples t-test. Two groups of people, one question. And for each of these, notice what is going to happen. We didn't touch upon this last time, so I'm going to do this today. In your alternate, the mean of the population, the subscript is going to be a group. Males. Mu of M is greater than mu of F. The subscript is the group. The first subscript is the group. Now you might say you want to look at speed. That is the attribute, that is the second subscript. The focal subscript is two groups. You want to make sure that you are able to bring out the fact that the groups are different from each other. The second subscript is going to be the same across both. Okay, the second subscript is going to be the same across both. Can it be different? Yes, it can, but that's a slightly more advanced question, which we won't get to. Probably towards the, till the end of the semester, we might not get to it at all, given that it's just 9 classes. Okay. So that is this is how you start off with an alternate when you're looking at an independent samples t-test. Two groups, the means of those two groups are not equal. Alternate always needs to have the inequality. And then you have the flip of that, which is H naught is mu M less than equal to mu F. There we go. If it's speed, then speed being the second subscript. If it's safety, safety being the second subscript. If it's comfort, C being the second subscript. Okay, so how do you run this test? We did a little bit of this last time, and I gave you an example which was really, really bad, and we'll talk about why it was bad. There we go. So the example that we did last week was speed, and based on our intuition, based on what we've learned since we were born, men tend to care more about speed, women less so, because if you look at any of the race car drivers, about 80% of them are probably even higher, are males. So that's something which has been inbuilt into me. Whether I'm right, whether I'm wrong, I don't know, but I can test it given this data. Remember what I'm trying to measure in here though, and this is a problem that's always going to face you in market research, which is you've asked the consumer. So this is a very explicit question. You've asked the consumer, how much do you care about speed? Okay. There is something that comes in when you're asked questions, which is known as social desirability bias, which is you want to answer what the person who is asking you the question wants to hear. Or if you're a contrarian, you want to give the answer which is exactly different from what the consumer wants, from what the surveyor wants to hear. So let me ask you a simple question. On a scale of 1 to 7, how much do you care about the environment? Okay. If I ask you this question, pretty much most of you will say 7. And then there are going to be some people who might be, climate change deniers, which they have all the rights to be. They would give you a 1. Okay. All the people who gave you a 7, if I now ask them, are you buying a product that is more expensive but is environmentally friendly? Suddenly, the number of people who care about the environment is going to come down. Okay. People might still say, I want to lie because I want to look good. Yes, I buy responsible products. Okay. The problem is when they actually go out and buy it, that's different. So attitude versus behavior, this is a question that had come in earlier. Again, I want to measure both. One is the expressed feeling of the consumer. The second is something that we are going to work with a lot later in the semester, which is the innate feeling of the consumer. Innate, inside. It's something which maybe even the consumer doesn't know about, but I'm going to extract it from him by looking at his or her answers. I'm going to extract it from him based on looking at his or her behavior. So that is something that we'll look at, and regression, which is our basic predictive tool that we're going to work on, is something that's going to squeeze that out. Again, there are lots of advanced techniques. We won't look at the advanced techniques because this is just the bare bones of marketing research. So let's start off with the question that we had looked at, which was speed. Speed, the importance of speed varies between men and women. And you decided it varies in the manner that males care more about speed than females. Okay, so I write down my alternate, which is, this is what I think is correct, this is what I want to prove. There you go. My alternate is written. What's my null? Mu m is less than equal to mu f. Let's run this test, analyze, and again, we've done this. I want to do this so that you can look at what's happening in here. Compare means, independent samples t-test. What is the variable that we are looking at? We are looking at the importance of speed. Okay, and the grouping variable was sex, gender. I've already done this, so I'm going to go through this relatively fast. 0 for females, 1 for males. Okay. If you have forgotten why 0 is females, 1 is males, go and have a look at the sheet behind you, where you can click on values and you can see that 0 stands for females, 1 stands for males. Done. This test is done. You press OK. See, this part is really, really easy. Okay. What did we find in here? Significance is 1.000, which is 100%. 100%. We want this number to be less than 0.05. This is 1.000, which means there's a 100% chance that your alternate is incorrect. 100% chance. What does this number tell you? What does significance tell you? The percentage chance that your alternate is incorrect. Again, statistically what I'm saying is incorrect, but as far as business goes, this is the best possible manner. This is the percentage chance that your alternate is incorrect, which means my alternate is incorrect, 100% chance. Why did this happen? This is a very, very specific scenario. Let's go and have a look at the means. Now, last week I told you if P is greater than 0.05, if you have rejected your alternate, there is no reason to go back and look at the means. This, however, is the case where we can go back, and again, I'm not going to ask you to, but I just want you to have a look at the means. Look at the two means. The mean for females is exactly the same as the mean for males. So 56 females, I added up all of their answers, divided by 56. 88 males, I added up all of their answers and divided by 88, and coincidentally, their means were exactly the same. This is a coincidence, which is why I told you this was a relatively bad test to start off with. So we start off with the worst scenario and go to the easier ones. So 5.25, 5.25, exactly the same means. This never happens. Almost never happens. Okay, you will always see one of them being higher than the other, except for a few exceptions, and you just happen to have seen that exception in here. This is the only chance ever where you will see significance 1.00. This is the only manner of form where you'll see, where you will notice that the significance is 1.00. We are going to work with some data where this equality does not happen, which is going to be pretty much all of the others. This is the only place where you'll see means being equal. So let's start off with something else. Let's look at comfort. Who cares more about comfort, males or females? If I were to ask you for your intuition, unlike speed, this might not really be very clear. But if you don't have a preformed opinion, it's fine. There is nothing wrong. This is the most important part. There is nothing wrong with going either way. Okay, just decide. It doesn't make a difference, because what's going to happen is, once I look at the P, once I look at the mean, even if I were wrong to start off with, my hypothesis is automatically going to self-correct itself. Okay. So let's look at comfort. What is my alternate? My alternate is, and this is based on, HA. This is based on my perception, and I might be completely wrong about this. I think women care about comfort more than men do. What is this based upon? What is this initial thought based upon? Pretty much nothing. It's primarily because I've seen my mom, I've seen my dad, and I think mom cared more about comfort than dad did. That's what my perception is based upon. One single data point, which might be absolutely incorrect. But I have something that I need to start off with, and that is what I'm going to start off with. If in psychology, you would look at a lot of literature. In marketing, academics, you would look at a lot of literature and argue for this hypothesis. That's not what market research is doing. Market research wants to know what the trend is. And the trend is, I believe, it's this. So I also need to write down an H naught, the exact opposite of this. H naught mu WC is less than equal to mu MC. So I have both of these. So now I am going to go and run the test. Analyze, compare means, independent samples t-test. Sorry. And what I'm looking at is comfort. Nothing else has changed. The only thing that I've changed is the variable in the analysis window. I've dragged out the old one, put in the new one. Okay. Press OK. And you're done. Let's look at the significances. Why are there two? In the first test that we are running, which is independent samples t-test, we don't need to worry about this too much. Okay. We don't need to worry about this too much. All that we need to look at is the top row. Why not the bottom row? You can look at the bottom row, and most of the times the results are going to be similar. Okay. You can look at the bottom row and the results are going to be similar. There will be an exception, and I'll show you that today. Which one do you go for? Either is fine, but most of the times what we do is we go for the top row, which assumes equal variance. What is assumes equal variance? I'll come back to this when we are doing the next test, because that's where it becomes a little bit important, not in here. Okay. So we have significance of 0.225. Is that less than 0.05? No, it's not. It's not less than 0.05, which implies that HA is incorrect, or there's a 22.5% chance that my HA is incorrect. I can't live with that high of, inaccuracy. So I'm going to reject my alternate. Now, I've rejected my alternate. Do I need to look at the means? No, I don't. The moment I reject my alternate, there is no reason to go back and look at the means. Absolutely nothing. Okay? So I stop here and say, what do I say? I say my alternate was found to be incorrect, which means my null is correct. So there is no reason for me to believe that there's a difference between males and females when it comes to comfort. Okay. So the alternate is incorrect, which automatically implies that the null is correct, which means there is no difference. Now, is there any difference between males and females on any attribute? Now, how do I write this? I can either go and say HA mu W for safety is greater than mu W for M safety, and go on and list down all the 12 attributes and have 12 alternates. That's way too much. Nobody's going to ask you to write that, because that is something where we move from actually having an alternate to having an alternate at the back of your head. I promised you, I think week 2, that you would slowly move away from alternates. We are going to move away from alternates. As of right now, however, I am going to assume that there are 12 alternates that we have written down, and for each of them there is a direction. And probably I just want to write that down in English, which is, notice what I'm doing. This is a plain, simple English manifestation of all the 12 attributes. Men and women differ on their preference of attributes in a car. So men and women differ on their preference of attributes in the car. There are 12 attributes. I have the option of writing 12 separate alternates, but what I've done is written in plain simple English and smashed all the 12 of them together. Notice that there is no direction in here. I have not said men greater than women for comfort, men less than women for safety, men greater than women for mileage, and so on. I've not said anything at all. So there is no direction. All I've said is they are different from each other, which means the focal thing is going to be mu M is not equal to mu W. The mean for men is not equal to the mean for women. Now, if this doesn't make sense, don't worry about it. For all attributes, which is the sigma sign, which is, it tells you for each and every attribute, you're iterating, looking at the first attribute, the second attribute, the third attribute, and so on. It's important to tell you out here, it's important for you to notice that we are not, it's very, very important, that we are not saying that there's a comparison across attributes. The comparison is only within an attribute. Safety, males and females. Speed, males and females. Looks, males and females. A separate attribute at each and every step. It's not all the 12 of them mashed together. It's 12 of them being analyzed separately. So in this case, writing down an alternate becomes a tough chore. So nobody's expecting you to. This is probably what's going to happen in your project. There will be times when an alternate is going to be something which makes sense, and there will be times when it just doesn't make sense. And that part is something which I'm hoping that you are going to learn as you move through this semester. Okay, so let's, yeah, go ahead, question?
Okay, so you know how for the hypothesis that you wrote that women for comfort were greater than men for comfort?
Mm-hmm.
If you had written that in the other way around and you said that men for comfort was greater than women for comfort, would your outcome be any different?
It wouldn't, because even that would be wrong. The test is going to be exactly the same. So no matter which one you run, what you'll see. So let's suppose I'll go with what you wrote, which is let me do this better. So HA, I'm hoping I've understood your question correctly, but if I haven't, just let me know. Mu WC is less than mu MC.
Yeah.
Okay, so let's suppose I started off with this. What would the null have been? The exact opposite of this, which is mu MC is greater than or equal to mu FC. Okay. The p-value would still have been the same. It doesn't make a difference in terms of what your direction is. Your p-value is always going to be the same. So you are going to cut this off too, which means there is no way for you to prove, or there is no way that you can say that the importance given to comfort by males is less than, or women is less than the importance given to comfort by men.
No, but what I meant is, what if you wrote HA mu for WC is less than mu for MC?
Okay, that's what I've written. Sorry, my handwriting is no. So this is what I've written, right?
Oh, okay, yeah.
Okay. Even if you run this, can you prove this? You still can, because P is less than 0.05. So your alternate, no matter which way you write it, whether you write it this way or you write it this way, it's incorrect either way, which means there isn't enough in the data which is telling me that these two groups are different. These two groups are actually very, very similar in terms of this particular attribute.
Oh, okay, yeah.
Now, and I understand exactly why this question is coming up, because there's a third alternative in here. Less than, greater than, and equal to. Okay? That equal to is never going to be a part of the alternate, right? Because we have said that you cannot test for equality.
Yep.
What statistics can tell you is less than is not a possible answer, greater than is not a possible answer. So based on the statistics, it's probably equal to, but I can't test for it. So no matter which way you write it, it's always going to end up being the same. We'll go through a lot more practice exercises and you'll see, where that makes sense. I understand that, for most of you, stats is something which you haven't looked at in a long time. So I'm simplifying this. If I bring in the concept of a one-tailed and two-tailed test, this will become easy, but I don't want to, because that's not something which should be the focus at all.
Okay, thank you.
All right, so
I have a question as well. When you are talking about whether it's correct or incorrect, you focus on the alternate, but would it be wrong to reject or fail to reject the null hypothesis?
Okay. Don't go with fail to reject. Again, there's absolutely nothing wrong with this, but always go with you cannot accept the alternate. Okay. Because the moment
so
you say...
focused on the alternate rather than the null.
Yes, because I'll tell you why. And again, if you were in a statistics class, they would tell you, yes, that's the way you want to go. When you say you fail to reject the alternate, there are two things that you're failing to reject, which is less than and equal to, right? But given that you are doing what's called a two-tailed test, you're actually also rejecting part of the null, which is the not equal part.
Okay.
So it's always better in business to say that you accept the null, accept the alternate, or you reject the alternate, rather than get into the null at all. And again, this is statistically what I'm saying is, not kosher, but it's easier for the manager to understand. And I can't.
In the slides it says.
Yeah, that's statistical.
No.
That's statistical.
Okay. And also in the tutorial, so I was a bit confused.
Okay. So I thought the tutors would tell you to use either accept the alternate or reject the alternate.
They have been saying for the null, but I have been saying the alternate, so I was confused.
I'll have a chat with them again. That shouldn't be a problem. Okay, so let's do something which will show us how to run all these tests together, and we will also be able to analyze a lot of the data together. So here it is. Here is what I had written the last time, the last sentence of that sheet, which is men and women differ on the 12 attributes. Which ones I don't know. I have not given any greater than equal to sign. All I've said is not equal to. So let's press OK. Again, this is not a comparison of comfort with safety. It's not a comparison of safety with power. We are analyzing each of these individually. We are analyzing each of these individually and separately. And you'll be able to see it in the results. Let's have a look. Okay. So I have them for comfort. I have the mean for females, the mean for males. Those are the means. For safety, mean for females, mean for males. For power, mean for females, mean for males, and so on. Now, the tests actually are below. So let's have a look at this test, all of these tests, and see what's happening in here. Okay. We are only going to look at the top row for now. Comfort, is there a difference? 22.5, no, there is not. Safety, is there a difference? Less than 0.05, yes, there is. Power, there isn't. Again, if I were to go with what my intuition said, I would say women care more about power than men do. That's not something that I'm finding. Speed, something that we've already looked at. They're actually equal. Styling, extremely close to 0.05, but not really 0.05. This again is one of those places where 0.05, you have to remember, is just a suggestion. If you want, you can accept this to be, significant and say P is getting close to 0.05, so I'll accept the alternate. Alternatively, if you don't want to, that's fine too. That 0.05. And again, when I come to your project description, when we talk about the project a little bit more, I'll remind you that just because you don't find a P of less than 0.05, that doesn't mean your life is at an end. Okay. So you're fine with that. So styling, I can go either way. I will say it's not significant. What about durability? Yes, it is. How do I say that? Less than 0.05. What about reliability? Yes. Maintenance costs, no. Reliability, yes. Warranty, yes. Non-polluting, yes. Look at gas mileage. This is one of those exceptions. I told you I would show you an exception. This is one of those exceptions when the one on top and the one on the bottom are giving you different results. Now my suggestion is, again, you can go with either, but this is an exception. This happens rarely. 0.058, it's greater than 0.05, so I will decide to reject my alternate. Last one, speed of repairs. That's going to be a very problematic story, and we'll talk about that again. Is not significant. So let's make a list of what is significant, and I'm going to write that down on a sheet of paper for myself because I am going to forget. Okay. So what we have as significant are safety, durability, reliability, warranty, and non-polluting. So there seem to be 5 different attributes where males are different from females. Of the 12, 5 of them males are different from females. The remaining 7 are not. The remaining 7, they seem to be the same. Notice that I did not talk about any direction. I haven't talked about any direction till now, at all. Okay. Because why? Because my alternate was they were not equal. So there is no reason for me to accept the alternate in 7 out of the 12 cases. The remaining 5 cases, I accept the alternate. Let's make this a little cleaner. And I am going to run my analyses with only the attributes that were significant, which were safety, power, speed, styling were not significant. Low maintenance cost was not significant. Reliability was, warranty was, non-polluting was, and the last 2 were not. If you are writing this down along with me, so there are 5 attributes that were significant between males and females: safety, durability, reliability, warranty, and non-polluting. These are the ones that I found to be significant. Okay. Now that I have a smaller number, probably I can, and again, this is not something which is needed, probably I can go ahead and say which one, males or females, care more about these attributes. So let's have a look at safety, for example. If I were to write an alternate for this, what would I say? Safety seems to be more of a female compassion, a female attribute. So females care about safety more than men do. That's what my intuition says. Okay. Durability, I don't know. I frankly have no idea. I know based on the data, because I worked with this data. But if somebody asked me while I was walking on the street, who cares about durability? I don't know. Who cares about reliability? Probably women, probably, but again, I don't know. Warranty, again, I don't know. Non-polluting, women, certainly. If you go to a climate change march, you will see that the number of women is going to be a lot more than the number of males, because probably women care more about, they have a maternal instinct, they may care more about what's going to happen to their kids, whatever be it. I don't know what the logic behind it is. I think that's going to be the case. So let me run all of these tests. Remember, for all of these, P has already turned out to be significant, which means that 2 of these are not equal. The second step, however, which is I need to look at the means, still needs to be addressed. So let's go back and have a look at this. I'll press the test. There you go. This, I know for a fact everything is going to be significant. All the significances are less than P equal to 0.05. Notice that? Let's look at the means. Who cares more about safety? Males or females? Females do. They're very close. If I were to show you these numbers and ask you who seems to care more about safety, you'd say these numbers are really close. But the t-test is using these 2 numbers, which are the standard deviations, to be able to show that there is 100% chance pretty much that in the population, based on the sample, women are going to care more about safety than men. So women care more about safety than men do. Let's look at durability. Who cares more? Again, women seem to care more about durability. Who cares more about reliability? Again, women. Warranty? Again, women. Look at the difference in non-polluting. Who cares about the non-polluting features of a car? It's women. Women seem to care a lot more about things as compared to men. It's just a gender thing. We'll talk about all these innate, characteristics of separate groups when we go a little deeper into the course. So you see that women tend to care a lot more about attributes. There will be times when it's going to be the opposite way, but we'll talk about that later. So I have run 5 tests. Actually, I ran 12 throughout 7, 5 final tests, which tell me males differ from females. And now, retrospectively, I can also give a direction. I had started off with not equal to. Men are not equal to women. Men and women care differentially. Now that I'm done with the tests, I can go ahead and say, not only are they different, I can also tell you who cares more. Who cares more? Women do, women do, women do, women do, women do. Women tend to care a lot more about attributes in a car as compared to men. But just those 5. On the remaining 7, there is no difference between males and females. You wouldn't think that just gender is going to reflect in so many attributes. It does. Let's do the exact same thing. Now, not for how important do you think an attribute is. The next question I'm going to analyze is, and let's write down the alternate for this. Which is, how satisfied are you with the attributes of the car? The car that you currently own. So remember, we have 4 groups of questions. I'm leaving 2 of those for you. 2 of them we are going to be addressing. So the first one was, how important is the attribute in a car? How important is safety in your car? The second set of questions is, how satisfied are you with an attribute? So how satisfied are you with the safety in the car that you currently own? So let's check. Let's run this. Before that, we write down our alternate. What is our alternate? Men and women differ on their satisfaction with the attributes. If I were asked to read this ever again, I wouldn't either, so I apologize, which is why I'm reading this out. Attributes of the car that they currently own. Men and women differ. Not that men care more, not that women care more. We'll do that retrospectively. In statistics, you can't do that. In psychology, you can't do that. Okay. What we are saying is, we are being non-committal. We are saying they differ. We are not saying how they differ. So let's run this test. Analyze independent samples t-test. We are not looking at car attributes. What we are doing is looking at satisfaction with the attributes. So there are 12 of them. There's an overall satisfaction. We'll leave that for later. I'll tell you why. Okay. Your groups are already defined, males and females. We found that, according to the list, in terms of importance of attributes, safety, women cared more. Durability, women cared more. Reliability, women cared more. Warranty, women cared more. Non-polluting, women cared more. Now, what about satisfaction? All these 12 attributes, what do I find? Significance, comfort still not significant. Safety, is safety significant? No, it's not. Is power significant? No, it's not. All of these are greater than 0.05. Not significant. Styling, not significant. Durability, significant. Warranty, significant. Non-polluting, significant. That's it. So there are 4 attributes on which the satisfaction differs by gender. I'm selling a car. I'm selling a Mercedes. My Mercedes sells to men, to women. I think 12 attributes are important. On 12 of those attributes, out of the 12 of those attributes, 8 of them, men and women, don't differ. They seem to be equally satisfied. The question is not whether they are satisfied. The question is, are they equally satisfied or equally unsatisfied? So they're equally satisfied on 8 of them. The 4 of them on which they are differentially satisfied are durability. Again, go through this really quickly. So durability, warranty, and non-polluting. Actually, they're just 3. I'm sorry, I misspoke. Reliability. Yeah, they're just 3. 1, 2, and 3. They're just 3 attributes on which they're different. Sorry, not 4. So who do you think is more satisfied? We know that women care more about these 3 attributes, all 3 of these. They care more about durability, they care more about warranty, and they care more about non-polluting. Okay. But who is more satisfied? Obviously, there's a difference across the genders. So let's run this entire thing. We can go back and look at the means right out here, but there are too many of them. So what we're going to do is just run the specific tests. Warranty was significant, reliability was not. There you go. I've taken out everything that was not significant. Just retained the 3 that was significant. And now let's go and see who actually is more satisfied. On all 3 of them, we found that women cared more about them. But which of the genders is more satisfied? Who is more satisfied with durability? Women are. Who is more satisfied with warranty? Women are. Who is more satisfied with non-polluting? Women are. So women care more about stuff, but they're easier to please. That's the result that we're getting. And this is the kind of result, no matter what data set we look at, this pattern seems to follow. So genders are different on a few things. Women care more about something, but they're more easy to please. So that's what I found from our analysis, which is an analysis of 2 groups, males and females, on 1 question at a time. Again, we are not doing a comparison of 2 questions at the same time. Okay, so this is the second box that we are looking at. Again, let's go ahead and make that box, because that box is very, very important. I'll give you a lovely box at the end of the semester, which is going to help you. So we have looked at 1 group of people, 2 groups of people, 1 question, 2 questions, 1 sample t-test. This is groups or segments. This is questions. And 2 groups, which is an independent samples t-test. Again, the first one, when we are looking at, is safety important? 1 group of people, 1 question. Second one, 2 groups of people, males versus females. Is safety more important for males versus females? 2 groups of people, 1 question. The third group that we are going to look at today is 1 group of people. Okay, 1 group of people, 2 questions. So the setup is, do people, because it's 1 single group, no longer are we splitting this into males and females. Do people care more about speed or safety? 2 questions, 1 group of people. Do people care more about speed or safety? And this is known as a paired sample t-test. Paired because it's a pair of questions. Paired sample t-test. It's a pair of questions that we're going to analyze at the same time. So it's a paired samples t-test. 2 questions, 1 group of people. What's our this thing going to be? Alternate going to be in this case? Our alternate mu. Now it's an attribute which becomes the first subscript. So let's call it mu of safety is greater than mu for speed. Okay. The importance of safety is more than the importance of speed, which seems to be, true for most people. Again, some of you might argue, and I'm nobody to say that you're wrong, is that no, given the kind of roads we have, I care more about safety. I care more about speed than safety because I want to make sure that I'm able to drive at 120 kilometers an hour. Sure, nothing wrong with that. If that's what you are starting off with, if the data backs it up, excellent. If it doesn't, you can always go back and change your hypotheses post facto. It's very, very important that you do so. No matter what your hypotheses, you always look at the means so that you have that sense of direction. You know what direction the results are going in. And as a result of that, you might go back and change your hypotheses. Okay, so let's look at this. Our alternate is that. What is our null? The exact opposite of this, which is mu of speed. Sorry, mu of safety is less than equal to mu of speed. So again, the entire spectrum is covered. The entire spectrum is covered. HA, which does not have the equality, and H0, which has the equality. I want to find out which of these attributes do people care the most about. Okay? People care more about, not the most about. Care more about. Is it speed or is it safety? Let's work through this. Analyze. Still in compare means. Paired samples t-test. This is called a paired samples. Later on, when we are comparing more than two questions, it is going to be called repeated measures t-test. It holds a pattern, and you don't see that pattern right now, but we will as you go along. So we are going to call it right now paired. After paired, it's going to become repeated. So let's start off with the easy version first, which is just two questions. Which of the two questions is more important? Okay. In a statistical scenario, all that we are doing is checking if two t distributions, which are the two answers, overlap or they do not overlap. Is there reason to believe that they do not overlap, which means they are different from each other? Again, we're never going to ask you any of this. So, two questions. The good part about a paired samples t-test is that it's really easy to set up. All you do is pick up the two questions that you are comparing, safety and speed. Click. You're done. You're done. So again, the SPSS component is really, really easy. There isn't really anything which is difficult about it. Okay. The most important thing is you looking at the table, and again, even if you have a table in front of you, it's the calculations you're doing at the back of your head, trying to figure out which test should be run. Okay. Once you know what test is to be run, getting that test wrong, actually conducting that test incorrectly, would require rare expertise. Okay. That doesn't happen. As long as you know what you're testing for, how you're testing it, your test results are always going to be correct. So there you go. Press OK, and you're done. That's it. Okay. Now, 2, 3. There are 3 boxes that we have. The second one, we'll look upon it in class number 8. As of right now, please ignore it. I've deleted that because it kind of creates a problem, because I don't want to introduce correlation to you right now. So we are just going to look at the first box and the third box. And SPSS is a little bit, strange in the manner, because all the other tests, all the other softwares go the opposite way around. It gives you the box with the test results last. And that's a pattern that you're going to see in every single test that you run. If you ran the same thing in SAS, you would get the results first and then the descriptors. SPSS just decides to go the other way. So let's have a look at what the result of our test was. We don't care about any of this. All that we care about is the last value, which is 0.000. So there's a 100% chance. There's a 100% chance that your alternate is correct. Or there's a 0% chance that your alternate is incorrect. Again, focus on the alternate being correct or incorrect. Let's not look at the edge knot, because that brings into question the equality component, the directional component. We'll just do it stepwise, so that makes it a lot easier. Okay, so this is what we got. Significance is less than 0. So my alternate is correct. What was my alternate? My alternate was, there you go. The importance of safety seems to be more than or I predict that the importance of safety is greater than the importance of speed. Okay. So my alternate is correct, but there's a second step that I need to do, which is look at the means. Confirm. Importance of safety is 6.64. Importance of speed is 5.22. It's exactly in the direction that I predicted, which is that the importance of safety is higher than the importance of speed. So coming back to the question which cropped up about 15 minutes back, what if I had written my alternate as HA because of some weird circumstances, let's say, that I grew up in, based on my culture, based on the people who I was driving around with. I said, I don't care about safety. Who cares about safety? I think the importance of safety is less than the importance of speed. This is my alternate. Sure, you are entitled to your view. There's nothing wrong with this. Now, what did the p-value show me? The p-value showed me that my alternate was correct. Excellent. So I just proved that safety is less important than speed. Not so fast. I also need to look at the means. What do the means tell me? The means tell me that the importance of speed is less than the importance of safety. So I'm going to go back, a post facto change, and say, yes, my test was correct, my p-value was in the right direction, but my means were in the opposite direction. A post facto change in your hypotheses, after the fact change in your hypotheses, which is I need to go back and change the direction of my hypotheses. Why? Because my means tell me so. Whether or not you accept the alternate is based upon the p-value. The direction of the alternate, you always need to go back and look at the means. Both those steps, please. Because if you miss the second one, there will be times when you get your answer wrong. Okay? There will be times when you get your answer wrong. So please go back and switch your hypotheses. No matter what you start off with, if you follow both the steps, you are going to get the correct answer every single time. Okay? Now let's do a few more, because it's important that we consider all the examples, get a little bit more practice out of these. Obviously you're getting a little bit in your tutes, but I'm hoping that once the tutes are done, once the lecture is done, you go back and experiment. That's the only way of learning marketing research, because what I'm giving you is going to stay there for the next 5 minutes and then disappear. The only way it stays is because you practice. Okay? And again, if I can help in any manner or form, just send me anything on Teams, and I'll be happy to have a chat with you. Okay, so we've looked at safety, we've looked at speed. Now let's look at something else. Okay. We've had a look at reliability. Reliability has come in quite a few times. Warranty has come in quite a few times. Durability has come in a few times. What's the difference between reliability, durability, warranty? Those are really abstract concepts, and frankly, you would think that there would be an overlap amongst them. If you want high reliability, you probably want high durability, you probably want a good warranty. Why is it that 3 separate questions were asked? Why is it that we did not ask just one question? That's based upon a lot of analyses that was done behind this survey. If you come with me in 3090, if you are with me in 3090, we'll look at techniques called factor analyses. We'll look at techniques called dimension reduction, which make your survey as small as possible. In this case, instead of asking a question on reliability, durability, warranty, why not ask one question which encompasses the 3 of these? We found out that would not work for us. What is the logic behind that? That's for 3090. So those 3 questions are very, very distinct. Even if you don't feel it, when you look at the 3 of these, even if you don't realize it, when you actually run the analyses, you will see that the 3 of them are different. Just a reminder, reliability was not significantly different across males and females. Okay? Warranty was, durability was. This is again based on a lot of research. We decided all these 3 questions were necessary. So let's go ahead and have a question. And again, this question might not make sense to a human if you looked at it, straight away. So the question might be, is the importance of warranty more than the importance of reliability? That's my question, and I believe that people care more about warranty than reliability. Think about this. And again, when you come to 3090, we'll go through a psychographic analysis and why the 2 of these are perceived differently. What is reliability? Reliability is when I'm driving down a street, my car doesn't break down. What is warranty? Assuming that it does break down, they fix it with no out-of-pocket cost for me. Okay? One of them is not being stranded in the middle of the road. The second one is financial, which is I don't need to pay anything. Everything is fixed by the company. So I think getting the car fixed is more important than the car not breaking down. Now, what does Mercedes do? A little bit of this was also financed by Mercedes. Mercedes, whenever you buy a new Mercedes, you become a member of what is known as the Mercedes Club. So all you do is you give them a call. No matter where you are stuck, within 1 hour they are going to be there. I don't know how they get to you in an hour. It's an average that they claim when you are in the middle of the outback, but that's what their claim is. On average, we take less than an hour to get to you. So what is it that it's claiming? It's claiming that we think it's reliable. So no matter where it breaks down, if it breaks down, we'll come and fix it. The second thing is 3 years, 36,000 kilometers, you have warranty. If it breaks down, get it to us, we'll fix it. So those 2 are actually looking at different concepts. And my belief is people care about money more than being stranded in the middle of a highway, which might be completely wrong, but that's what my feeling is. And since I've written my alternate, I also need to write my null, which is The importance of warranty is less than or equal to the importance of reliability. Okay. So I have my alternate, I have my null. Now I have to run this test. Let's run the test. Analyze. Compare means. Paired samples t-test. What are the variables I'm considering now? I am considering reliability and warranty. Press OK. .000, which means the two of them are evaluated differently. People care about one more than the other. So I'm going to go back to my alternate. My alternate is correct. I'm saying my alternate is correct without even looking at the direction. Okay, I need to look at the direction. My alternate is correct. Do I need to flip it? Do I need to create a post-facto hypothesis? I need to go and look at the means. Let's go and look at the means. Warranty 6.29, reliability 6.78. Oops. It's in the opposite direction. It's opposite from what I had predicted. I had predicted people would care more about the financial aspect rather than the reliability aspect. That's not what it is. People seem to care more about reliability than the warranty, which is why if you ever buy a Mercedes, your club membership goes on for 5 years, your warranty goes on for 3 years. So that is giving people extra signals, telling them that your car is reliable. It also has a warranty, but I see that warranty is not as important. It's not that it's not important, it's not as important. If I had $100 to spare, I would rather give you more reliability than I would give you warranty. Okay. So comparison of two attributes. You need to first have an alternate. Run a paired samples t-test. Look at the p-value. But after that, please make sure that you look at the mean. If you do not look at the means, you'll get it wrong like I did. So I still have another thing to do, which is to say this alternate is actually incorrect. I need to flip it. I need to create a post-facto hypothesis, which is mu for warranty is actually less important than the mu for reliability. This is my new alternate. Make sure that you look at the means before you finalize your results. Okay, so alternate, go in whatever direction you want to. Look at the p-value. Check whether or not the p-value is less than 0.05. If it's less than 0.05, your alternate is correct. Otherwise, no need to go any forward. There is no difference across the two attributes. There's no difference across the importance of the two attributes. Why even look any further? If, on the other hand, p is less than 0.05, you accept your alternate, but you need to check whether you need to flip your alternate. Always check that. If you don't flip your alternate when it needs to be flipped, you're giving the manager the exactly opposite advice of what he should be getting. If I had not flipped my hypothesis, I would have said, put more money into warranty. Nope, that's not what we want. We want more money in reliability. That comes from the second step, which is looking at the means. This is automatically done in statistics when you do a one-tier test. This is not automatically done in business because, well, not in business research, because we are looking for patterns rather than theorizing a pattern and then proving it. As you go into machine learning, as you go into AI, even deep learning, the focus no longer stays upon what does theory tell me. If I see a pattern and I can make money out of it. That's it. That's all that I care about. The focus is finding a pattern, telling the manager how to make money out of it. You've heard of marketing analytics. You've heard of analytics. What is analytics? Analysis is based on why a pattern exists. Analytics, I don't care about why the pattern exists. Given that the pattern exists, how can I utilize it? So when you are with me in 3090, when we look at analytics, even this p-value, it's going to disappear. You're never going to look at a p-value. I see patterns. How do I use those patterns to sell better? So that's the third type of t-test. Again, one sample t-test, one question that you're analyzing for the whole sample. Independent samples to t-test, break it into two groups, break the sample into two groups, and then are the two groups different from each other? Paired t-test, two questions answered by the entire sample. Does the sample evaluate these two questions differently? In terms of examples, do people care about speed? People, one group, speed, one question, one sample t-test. Do males and females differ on the importance given to warranty? Males, females, two groups, one question, warranty, independent samples t-test, two separate samples. One group of people, two questions. Do people care more about speed than power? Two questions, one group of people. It becomes a paired sample t-test. Final thing that I want to show you, which unfortunately you are not going to be doing in your tutorials given the time limit that's available to you. An independent samples t-test can also be run, and again this is more for footnote. If this were a teaching case, if I were teaching you through a case methodology, which I do at other levels, this would be a footnote, but it would be an important footnote. Let's look at a category in there and then I'll set the whole thing up. The category is cars. The car that you own. You either own an American car, you own a Japanese car, or you own a European car. You own one of these three types of cars. My question is, do people who own these cars, depending upon the type of car that they own, do they value safety differently? Do they value safety differently? Okay. Three groups. Do they value safety differently? If this is the setup of the question, you cannot run a t-test. Okay. If this is the setup. I can, however, ask you, people who own American cars, do they value safety differently from people who own Japanese cars? Now it's two groups of people, Americans and Japanese. One question, which is safety. The basic focus of this point is that although the number of groups is greater than 2, you can still pick up two groups and analyze them separately. How do you do that? So the question that I had, let's write this down in terms of our alternate, in terms of running the test. So the test says my alternate is Americans, people who own American cars, they are patriotic, they are loyal, probably a little poorer. So they would probably care less about safety. American would care less about safety as compared to a person who owns a European car. European cars are slightly more expensive. They sell to people with a little higher education and who are a little bit broad-minded. So that's what my perception is. I might be completely wrong with this. Okay, But this is what my perception is. This is what my alternate is. My alternate says people who own American cars, they value safety less than people who own European cars. How do I run this test? It's two groups of people. It's two groups of people. One question. So it's perfect for an independent samples t-test. But how do I run this? Remember, we are doing American and European cars, so it's 1 and 2. Analyze, compare means, independent samples t-test. The question that we are analyzing is, let's reset everything. The question that we are analyzing is safety. What's the grouping variable? Type of luxury car. But type of luxury car has 3 different possible answers. With 3 different possible answers. I am comparing only option number 1 and option number 2. So that is what I am going to enter in here. If I were comparing American cars with Japanese cars, this would be 1 and 3. If I were comparing Japanese cars to European cars, it would be 2 and 3. But right now I'm just comparing 2 cars, which are American and European. So I have conducted an independent samples t-test on a question which has more than 2 groups. But the analysis itself just contains 2 groups. Let's run this test and see what's happening. Press OK. There we go. Anything to believe that what I said was true? Absolutely not. Look at this. Significance is 0.964, which means there's a 96% chance that your alternate is false. There's a 96% chance that your alternate is incorrect. There's no reason for me to go and even look at the means because my alternate has already been shredded to bits. Okay, so that is the third type of test that we've already looked at, but now we are considering an independent samples t-test with 2 groups out of 3 analyzed. It's still an independent samples t-test, but we are comparing only 2 groups at one time. What if there are more than 2 groups? What if I want to say American, European, Japanese, 3 types of cars? Is there a difference in terms of the importance of safety given to these 3 groups, from these 3 groups? 3 groups, if you want to compare at the same time, you cannot use an independent samples t-test. Why did I use an independent samples t-test in here? Because there are just 2 groups. I have taken 2 groups out of 3 and analyzed them. What if I wanted all 3? Can't do it. Can't do it. To do that, we are going to move to the next part of the box. So let's go back and draw the box. After next week, you will have the first proper formal, not next week, week 7, you're going to have a first formal box that's given to you, but I want to build this up rather than give it to you because it's very, very important that you understand how it's being built up. Number of groups is 1, number of groups is 2, number of groups is greater than 2. We are still working with 1 categorical variable that has not disappeared and 1 continuous variable. Number of questions is 1, number of questions is 2. Later on, number of questions is greater than 2. 1 sample t-test, independent samples t-test, paired samples t-test. This is the next box that we are going to consider, which is 3 groups of people or more. 3 groups of people or more. I'm going to spend 2 minutes in here because it's important that you see why this part is important. Okay. So, what are the 2 types of categorical variables that we have? We have nominal, we have ordinal. Let's assume, and we are just making an assumption, that we are working with a nominal variable. Okay. So let's do nominal variable with multiple categories would probably be race. So let's go with race. So we start off with one group. We are not looking at races. What we are looking at is one category. So everybody is from the same race. It doesn't make a difference. We are not classifying people by race. Then we look at a comparison of Caucasians and blacks. This is 2 groups of people. What is the test that we are going to run? Caucasians and blacks. We are running an independent samples t-test. The percentage of times, or the percentage of blacks who are incarcerated as compared to Caucasians. One of my students did this project. So the percentage of blacks, the percentage of Caucasians who are incarcerated. Do a test. What kind of test? Independent samples t-test. It's a comparison of 2 percentages. Okay. Now, let's go to 3 races now: Caucasians, blacks, and Asians. 3 categories. What am I going to do? I am going to come to this box, and this box is known as ANOVA, Analyses of Variance. Analyses of variance, and this guy is going to stay with you till the day you do statistics. Every single statistical test, not big data, but every single statistical test, not artificial intelligence, none of that, but statistical tests always focus around analysis of variance. That's what statistics revolves around. Even t-tests, frankly, it's an analysis of variance. It's just that it's so small that you don't see it. But as you go forward, this term, which is ANOVA, is going to follow you for this entire semester, for the next semester in 3054, and in 3090 also. Okay. So, 3 different groups of people. What kind of variable is this? Categorical variable. What kind of categorical variable? It's a nominal variable. Why? Because there is no order, so it's a nominal variable. So 3 groups of people, I am going to be running an ANOVA. Let's get a 4th group in. Okay, Caucasians, blacks, Asians. Let's do Hispanics. 4 groups of people. Still an ANOVA. 5 groups of people. Let's do Pacific Islanders. 5 groups of people, still an ANOVA. Okay, let's suppose there's a 6th group of people, others, mixed race. Still an ANOVA. No matter how many groups of people in a nominal variable, you're always going to be running an ANOVA. Okay, now instead of a nominal variable, let's look at an ordinal variable. So ordinal variable, education. We are looking at people who have an education of less than 10 years, which means you dropped out of school. 1 group of people, 1 question, 1 sample t-test. People who dropped out of school, do you care about safety? It's a 1 sample t-test. 1 group of people, I'm not comparing them with anybody else, 1 sample t-test. Instead of doing less than 10 years of education, let's do less than 10 years of education and a second group, which is 10 to 12 years of education, which means you finished school. 2 groups of people, independent samples t-test. 3 groups of people, 12 to 15, which means you finished your undergraduate, you finished your college. Assuming you're in Australia, if you're in the US, this number is going to be 16. Okay? 3 groups of people. What do? It's 3 groups of people. It's a categorical variable, but ordinal in nature. Why? Because education is increasing. 3 groups of people, it's still an ANOVA. Let's look at the ones who also do their masters, which is 15 to 17. 4 groups of people, it's still an ANOVA. It's an ordinal variable, a categorical ordinal variable. But, and this is the important part, if you have a 5th category, which is you did a PhD, you did a postdoc, greater than 17 years. Now I have 5 categories, 5 possible answers. Ordinal variable, if you have 5 possible answers, what can you do? You can assume it to be continuous. Nominal variables, never ever. So nominal variables doesn't make a difference how many categories you have. You always have to run an ANOVA. Ordinal variables, if you have 5 or more possible answers, you can assume it to be continuous. And if you can assume it to be continuous, does it fall in this box any longer? It's no longer categorical and continuous. It's no longer a part of this box. We have some lovely tests to work with. We always want to work with as many continuous variables as possible. This is a scenario where we have 1 categorical and 1 continuous. So if the number of values in your ordinal variable is 5 or greater, you can assume it to be continuous. You are no longer going to be using ANOVA. When do you use ANOVA? When we have 1 categorical variable and 1 continuous variable. 1 categorical, 1 continuous variable. Okay. And in the categorical variable, you have more than 2 groups. That's the box we are looking at. So there are more than 2 segments of people, but they are focused upon analyzing, or we are focused upon analyzing only 1 question. How do you run this? I'll do ANOVA again. I'll do a recap on ANOVA again when we start off in week 7. So that 145 limit is coming in drastically close. So what I'm going to do is I'm going to run the test quickly and show you how it's done. Analyze. This is the last test that we are going to do, which falls in compare means. Compare means one-way ANOVA. And this is the correct name for the kind of test that we are doing, which is more than 2 groups of people and 1 question. Nobody ever calls it a one-way ANOVA. It's called an ANOVA, but it is technically the correct name in statistics is a one-way ANOVA. Why is it a one-way ANOVA? Because it's 1 question. 1 question being analyzed across multiple groups. But if you say ANOVA, that's fine, because the entire world calls this an ANOVA instead of calling it a one-way ANOVA. So one-way ANOVA, unfortunately, ANOVA is not neither ANOVA or nor the test that we are doing after this is a very happy test. It's got multiple steps, and you have to remember to do them in the correct order. It's not simply throwing in a bunch of variables, which it was till now. We will go back to throwing in a bunch of variables very soon. ANOVA and one-way ANOVA, ANOVA and repeated measures ANOVA, which is the test that we're going to do next, are the 2 problematic tests in terms of the steps that you need to follow. Okay? So let me walk you through this once, and I'll go through this with another example next week. What is the question that I want to analyze? The question that I want to analyze is safety. Okay. Now, what is the variable which I'm going to use to segment the market? Let me use age. Safety and age. Does the importance of safety vary by the age groups? It's possible that young people who are carefree, they don't care about safety. Mortality is not a big deal. People who are old, mortality is very salient to them. They want a car which is as safe as possible for them. Doesn't make a difference if it takes somebody else out, but it should be really, really safe for them. Okay. So I believe that the importance of safety varies by age. Okay. What is my alternate? Impossible to write one. Very difficult to write one. I shouldn't say impossible, but all I can do is write it in plain simple English. For t-tests, mu works wonders. Instead of writing 2 sentences, you are down to 3, symbols. Whereas when you're writing an ANOVA, it's different. An ANOVA, you're better off with English. You say the importance of car safety differs across ages. Differs means they are unequal. There is inequality that you are putting in to the alternate. So the alternate for an ANOVA is going to be the variable differs by the factor. Now, why is this term factor used? SPSS is not a marketing software. It's a statistical software. So they don't use the term segment, obviously. They use the term factor. It is functionally exactly the same. It's groups of people. Okay, groups of people. That's it. Okay, so let's start off with how to run an ANOVA. The setup is done. The setup is done, which is the question that I want to analyze and the age, which is the segments that I want to analyze. I press OK. What do I find? It's not significant. So my alternate was there is a difference across the age groups in the importance of safety. What is my finding? There is no difference across the age groups in the importance of safety. This is easy. Done. I'm done. I have absolutely no problems. If there is no significance, if there is no significance, you stop. There's nothing else to do. Happy days. Okay. There's no difference across age groups in terms of safety, so I shouldn't even be looking at it. However, if this turns out to be significant, then we have multiple other steps to go through, okay, which is what I will look at next week. And I'll stop here. I think I'll stop here because rather than go through the entire process today, your Moodle should have. Okay, so your Moodle, I'll make sure that this is made available. Your ANOVA tests and your paired sample t-test will be made available to you hopefully tomorrow, and you can have a look at them. And any questions that you have, feel free to ask. Okay. In the meanwhile, I'll stop right now. If anybody has any questions or anything, I would love to answer those. Nope. All right, so in which case I'll see you. Well, I'll put on a recorded lecture next week. Till then, and again, if you have any questions, feel free to send me a message on MS Teams and I'll get back to you ASAP. Okay? All the best, guys. Take care.
Thank you, Rahul.
Bye.
Thank you.
Thank you.